All right, the last video for PA-6, here we go. So we're going to start in the Jupyter Notebook. We're going to go backwards on the requirements. We're going to start with the racetrack behavior, and we're going to crash the car. We're using the R track here. So we're purposely driving into the wall by constantly setting a constant acceleration. So here's our starting position. We're going to drive straight up. It might take a little while for the velocity to get going and for all of the actions to take place. Well, this time it really took a while. But here you can see we're closing in on that wall, and then we hit it, and then we reset here. Now we're going to drive into the wall. Hopefully we got the same starting position, so it's still going to take us a little while, get a little velocity going, a bit of acceleration, here we go. And then we've got reset down to the bottom, great. So here we are going to now look at state transitions. We have now switching over to the O track and soft crash behavior. We have three models that we pickled, so we're going to just pull them back up and just run through them. Each one gives the current state, the action we tried, whether that action took place, so this is the non-deterministic behavior, the subsequent state, including the position and velocity, the destination, whether it hit a boundary or not, and obviously whether it was done. So that was Q learning. This one's SARSA. Looks pretty much the same, although it's going to be a little shorter. And value iteration is also, same kind of stuff. You can see that one kind of in the middle. Now we're going to train. So these are the first requirements on the video. Here at the 1:40 mark. So we're going to demonstrate one sweep of each one of these algorithms. So the first one's value iteration, just one sweep through that value matrix update. And then for Q-learning and SARSA, that's one sequence, one episode that we just ran start to finish. And then we're going to see where did we exploit versus where did we explore. So I'm going to go ahead and run these. We're going to actually run this sort of twice. We're going to do one sweep of all of these. And you can see here in Q-learning, here's our original state, here's our action. Did we exploit versus we explore? It looks like there's a lot of exploiting, but there's definitely some exploring going on here too. We set this one here at a 30% epsilon, so we should be getting a decent amount of exploration. The former value, the updated value, here's the reference value for Q-learning. That's the max of possible values when we look at the state action pairs that we can use. So we can see we're running in the boundary a fair amount of time before we actually do anything constructive. And so that's Q-learning. It's probably not going to finish because, of course, it has nothing really that knows, so it's going to get capped out on parts of that sequence. So this next one is SARSA. We're at the 3-minute mark. Same basic parameters. It's only doing one episode. And then you can see same kind of thing. Did it exploit? Did it explore? What was the former value? What was the updated value? What was the reference value? And for SARSA, it has to be on policy. We're going to see that in the debugger in a second. And then we're going to just kick off the value iteration. This one will take a little while to run. So we're just going to let it run while we switch to the debugger. We're going to restart the debugger here. It's the same code that we just saw in the Jupyter Notebook. We're just using the debugger this time. So we're just going to step. And here we're in SARSA. We're going to go ahead and initialize the values. Again, ranging between -1 and 1 on this side here. We might have made a better choice if we wanted. But here you can see the algorithm implemented. So the action choice, that's the epsilon greedy choice. What action did we take? The criterion is whether we exploited or explored. We're going to take a future state. That state includes multiple things like the reward that was received from taking that state. And you can see we're going through this loop. We're updating the Q values here. And this is SARSA, so it has to take on policy action. So that's this action prime. So you can see 1 minus learning rate from the current value, discounted future value, plus the reward. So there's nothing fancy there. We're at the 4:30 mark. I'm going to pause until this will take a second to get us to Q-learning. So I'm going to pause here. All right, we're back. We're looking at Q-learning here. I'm going to start stepping through this. Again, initializing the values. The important thing here to see is that we are able to take off policy actions by looking at this max of future state values. And I'm just going to let that run as well. Let's see, action choice, again, this is epsilon greedy, take the future action, and then we're able to update using this future state action values. So kind of being able to look ahead and off policy, part of Q learning. I'm going to let this run at the 5-minute mark here until we get to value iteration. All right, we're back. It's basically at the 5-minute 30 mark. We're about to do value iteration. That's part of the code for that, but we're just going to take a look. This is not very exciting, but this is one sweep of the value iteration. Obviously, a lot of it is just taking the -1 for the action step, except at the finish line, which we may not even see. You can see a little bit of variance, but we're not going to really see anything interesting here. So let's go back to the debugger. And here we're going through every state and action. We can see the current value. And this time we've taken advantage of the fact that we have the model, so we have all of the possible next steps with their probabilities. So we're able to update this data and the qualities here. You go down here, you can see that we're going to update the state based on the maximum of that and the policy at the same time. So taking full advantage of the model, so we're going to go ahead and let that go. So the debugger is just going to finish off here, but that basically gets us through all of the requirements at the 6-minute 30 mark. So enjoy. Last video. Thank you very much.